Welcome to the Rich Report, a podcast with news and information on high-performance computing. Today, my guest is from Intel. We have Joe Yaworski. He is the Director of Fabric Product Marketing at Intel. So, Joe, happy holidays.
Happy holidays, Rich.
Well, thanks for coming on the show, Joe. I didn't get a chance to catch up with you at SC17, so I thought we could take this opportunity to hear what's going on with OmniPath and other networking activities at Intel. But how did the show go for you, Joe?
The show went really well for us. This was basically a little bit more than a year and a half since we started to ship OmniPath in volume. So now we have an established technology with several hundred accounts installed. With that being said, a lot of our partners and customers were exhibiting at the exhibit hall, so great presence at the show, and pretty pleased where we are at this point with OmniPath in the marketplace.
Well, terrific, Joe. I heard a little bit about that with some talk about the top 500, but I've brought your slides up. Why don't we go through that, and then we'll do a Q&A at the end.
Sounds good. This is an overview of OmniPath, its architecture, and wanted to get into performance information and in particular set the record straight on some information that has been published in the marketplace, and we wanted to make sure that your listeners got the straight scoop. So moving on to slide 2. Take you through a brief introduction into OmniPath, just for your listeners that may not be aware of OmniPath at this point. Like I said, we will be setting the record straight on some performance information, and then finishing up with just some of the key features of OmniPath, as well as where to get more information on OmniPath off the Intel website. Intel Omni-Path Architecture. This is a complete end-to-end product line. Adapters all the way through to different form factors of switches for some of our partners that actually use the silicon to develop their own products, as well as we provide software and even cables to tie it all together. With that being said, in the lower left on the slide, I do want to point out that this is built on some of the industry's best technologies. Intel back in 2012 did a couple of key acquisitions. One was from QLogic. It was the QLogic's InfiniBand team, as well as a little later in 2012, we acquired the Interconnect team and IP for the Aries technology from Cray. So what we did with OmniPath is take those two key technologies and use key parts of them to basically build out OmniPath. And in addition, we added in some intellectual property from Intel to basically build a product line. And essentially, we're building on existing technologies and improving on those technologies. So a very stable product line right from the start. In addition, we also released this product line so that it was price performance optimized. We use a 48 radix, or putting it another way, 48 ports on our switches. With that in mind, InfiniBand is still using 36 ports. And so we have a price advantage, especially as you begin to build out clusters, because we require a lot less switches, cables, rack space, cooling, and so forth as a result. One of the other decisions that we made was to leverage the Open Fabric Alliance software. That gave us a very mature host stack for OmniPath, but it also gave us full compatibility with InfiniBand. So we were able to leverage that compatibility to allow customers to easily move from InfiniBand to OmniPath, as well as we were able to build a fairly substantial ecosystem. We call it the Fabric Builders Program. We today have over 90 members that are part of it. It's all of the leading ISVs in the HPC community have joined and are supporting OmniPath with their software. Also, storage and other key members are in that Fabric Builders program. Some of the other key things about this, since we're leveraging a lot of existing technology and improving on it, we ended up with a very good performing system. Some of the key things are latency, message rate, the characteristics are very good in comparison to existing technologies. It gives us, therefore, very good application performance. With that being said, I'm not here to say that we are 20 or 30% or even better than InfiniBand, which has been some of the comments by one of the vendors in the industry when they talk about their products versus OmniPath. No, we are very good performance in comparison, but going back to that price performance, we are an excellent value. Then in addition, we've added features, and I'm going to point out just two of them, that really make it an innovative technology. We have a technology called traffic flow optimization. This was Intel intellectual property being brought in, and essentially it completely removes latency jitter from the fabric for high priority traffic. So for those MPI applications where you want the best time to solution and very consistent run-to-run performance, TFO is a key technology in achieving that. And then the other is packet integrity and protection, or PIP for short. That is a no latency error detection and correction implementation that we have. The industry, including InfiniBand, uses something called forward error correction, which can double switch latency or double the time to move traffic through the fabric. With packet integrity protection, again, no latency impact for doing error detection and correction in the fabric, which means that as traffic moves through the fabric, it is guaranteed to be correct at the receiving node, whereas if you don't have it turned on, that receiving node will occasionally get errors or receive packets that are in error, which means it has to do an end-to-end retransmission. It has to go back to the sending node to get a retransmission. This can cost many microseconds of latency. With that being said, OmniPath, we do all those corrections right in the fabric, and this is on all the time as a default. So it's a real advantage when you're looking at a fabric that's running at 100 gigabits per second performance, that you don't have errors occurring in the fabric, and especially when you're moving that amount of data at that speed. So it's been a phenomenal first 18 months for OmniPath. We started to ship OmniPath in volume at the beginning of 2016, essentially in the March timeframe. And in that first 18 months, we've had great acceptance by the industry. If you take a look at the top 500 list as being a good proxy for success in the marketplace, right now, OmniPath represents 10% of the overall performance of the top 500 list. Again, in just the first 18 months, we've been able to achieve that. Since just the last listing, which was done in June, to the current one, which was in November at Supercomputing, we've increased our total flops by 20%, as well as our listings in the top 100. So we are getting excellent acceptance of the OmniPath fabric in the top 500, especially at the top, where performance, scalability, stability are all important. And these are customers that typically do an extensive analysis before acquiring their cluster, and in particular the interconnect that ties the cluster together and really is one of the key factors for its performance. So we've done exceedingly well with those major customers. And if you look at the overall top 500 list and narrow it down just to the 100 gigabit space, so essentially OmniPath, other technologies like InfiniBand EDR, we connect 60% of the servers that are using 100 gigabits as their interconnect on the top 500 list. And then finally, 80% of the top 20 utilizing 100 gigabit fabric utilize OmniPath. So we've gotten an excellent pickup in the marketplace for OmniPath on the top 500 list. Some of our key customers are Barcelona Supercomputing Center, one of a very large installation around our latest generation of Xeon processors, sometimes called Skylake. Texas Advanced Computing Center is on their third major acquisition of OmniPath and has actually increased their listings or their position on the top 500 list as a result of this into that top 20 space. And then one of our first customers, in fact, our very first customer, was Pittsburgh Supercomputing Center. If there was a customer that was going to experience a new technology and all the problems that go along with it, it would have been this customer. Things have gone so well, they have established the OmniPath users group, and we just had the meeting at Supercomputing. Went extremely well. We had customers presenting how their installations went, the performance, and so forth. We've also opened it up to questions and answers from the audience, and about 60% of the audience was OmniPath users. 40% were basically there to hear about it, and got very good feedback and question and answer. So from our perception, this is an excellent indication of the success of OmniPath and the performance and the stability. I would recommend to all of your listeners that this is an organization that you might want to join if you want to hear more about OmniPath and get it directly from our users. We are in competition, and specifically we're in competition against InfiniBand EDR. And there was a recent article that was put out that, frankly, we've got to set the record straight for. Intel is very key on full transparency, performance information, and reporting of it. We consider it critical. So when we publish performance information, we publish the hardware and software configurations, key runtime settings, the details of the benchmark software versions. We try to make sure all of the information is correct, it's comparable when we do comparisons between the two technologies, and it's repeatable. So we fully document everything with this. Unfortunately, in this article, lacked all of that detail. But what was trying to portray in that article was that InfiniBand EDR is substantively better than OmniPath in terms of performance, and that's where I'd like to set the record straight. This is the level of documentation that we give, and I'm going to go through the three key benchmarks that that article portrayed. And as you can see, and this is a lot of data, but we try to provide all of the data on the hardware, software, configurations, and key settings that might need to be done so that a customer can make sure that they can, if they want, replicate the tests. So the first test that was discussed in the article was ANSYS. And in particular, when we redo the tests that were run for that, we show comparable performance between us and EDR. We also show excellent scaling. We're now pushing 91% scaling efficiency. So as you add that next increment of nodes, you're getting excellent performance out of it. With that being said, again, we go through and we make sure that we publish all of the details of not only the hardware that was used, but the software configuration. And one of the key points here is with the latest ANSYS software level, compared to the earlier one, especially on this test, you get a very sizable performance difference. Now, I'm not saying that they would use a newer version versus an older version to do the comparison, but it's one of the points that we make. We try to make sure everything is comparable, fully documented, and so forth. Moving on to slide 8, the LS dinah benchmark. On this one, we're getting 2 times the performance than was reported in that article. So something's wrong in what was run versus what we can achieve when the configuration is properly set and comparable to what was being benchmarked. So with that being said, it calls into question again the transparency. If you're not going to publish full details of the configuration settings and so forth and make sure that the results are repeatable, you end up potentially reporting misinformation. Again, this was VASP performance, and when we look at it, we're looking at anywhere from 1.8 to 2.2 times better performance and excellent scaling across up to 32 nodes for VASP. And when you look at it versus the article, again, we want to set the record straight. The performance of OmniPath is excellent, and as pointed out here and on the LS dinah as well as on the ANSYS benchmarks. When we do the testing, we try to do it in several ways. One is comparing straight up different MPIs to different MPIs between InfiniBand, EDR versus OmniPath. But then we try to optimize performance, and as an example, this is picking the best result for each of those technologies between the different MPIs that are out there, Intel MPI versus OpenMPI. And what this shows is basically OmniPath performs well in some cases. In some cases, it's slightly behind InfiniBand. On the average, they're about comparable. And so with that being said, we're not here to say that there's a 30 or 40 or greater percentage performance difference like was analogized in that article. What we're here to say is you get very good performance out of OmniPath. Moving on to slide 11, we give you the full details about everything was run. Slide 12 also shows that. Moving on to slide 13, where OmniPath does show clear leadership is on its price performance, where we've positioned OmniPath on a price per port, as well as leveraging that increased radix for our switches, 48 ports versus 36 ports for InfiniBand. As you build out a cluster, you can get a fairly sizable difference in cost. Now that difference in cost can be used to build a much better cluster. You can buy more nodes, more storage, or you can basically save money for your cluster that you're buying. But generally, you're going to end up with a much better cluster with OmniPath overall, because where we positioned it on a price per port, as well as leveraging our radix advantage in the switching technology. So you'll be able to buy more compute for your cluster at a similar price that you would pay with the competing technology. Moving on to slide 14, and just to summarize, this is proven technology. We're installed in hundreds and hundreds of accounts now and successfully installed. It is built on some of the leading technology that is out there from Cray Aries as well as InfiniBand. We leverage the Open Fabric Alliance. We've added significant features in that really do make a difference in your operation of your cluster as well as the performance of that cluster through things like traffic flow optimization, which removes that latency jitter through the fabric for high priority traffic, giving you better time to solution for your applications, as well as better run-to-run consistency for those applications. Because we do leverage the Open Fabric Alliance, we are completely compatible with applications written for InfiniBand, which has allowed us in part to build a very robust ecosystem. So whether you're using ISV software, community software, the ecosystem for OmniPath should cover all of your applications that you want to use with OmniPath. We encourage you to visit the Intel site, so it's intel.com/OmniPath, all one word, and you'll get right to OmniPath for additional information. So again, thank you for the opportunity to go through these slides and set the record straight.
Well, thanks for that, Joe. I had a question about, I think it was slide 13. As far as, could you characterize what is the typical cost for a big cluster that they're spending on interconnect? Is it 20%? Is it 5%? What are you seeing out there?
You know, typically it's going to range with OmniPath somewhere in that 20% range. Mm-hmm. As you can see here, we have about a 20% advantage in this example on slide 13 over the EDR technology. And that's as a result of where we priced it on a price per port basis, as well as leveraging our increased port count per switch. Gives us a more efficient way to build a fabric.
Okay, and does that vary, Joe, for a very large scale, like a top 50 kind of machine versus a top 600 or something like that?
Yeah, you tend to get increasing level of benefits due to the port radix difference. Mm-hmm. As you go further and further for larger and larger clusters, and it comes into play because you need less switches.
Right.
You need less cables, and as a result, the overall cost tends to be less. One of our customers in the top 10 was able to acquire 2 additional petaFLOPS versus of performance than if they had acquired InfiniBand EDR. So it definitely does make a difference in both the level of performance that you can acquire as well as, in this case, the positioning on the top 500 list.
Yeah. So they were able to buy more compute for their money as a result of this, going with this architectural path with the OmniPath. That's interesting. So Joe, I know you didn't comment on the roadmap for OmniPath, but do you think that Intel is on a par with future generations of InfiniBand in terms of when they could deliver, say, 200 gigabit technologies and beyond?
Rich, that's a great question. The way we look at it, we will bring out the technology when we feel that it will have the best impact on our customers and their needs and utilization of the technology. The next stair step here in terms of bandwidth will be going from 100 gigabit to 200 gigabit. When you look at 200 gigabit technology and trying to drive that bandwidth, it really needs to dovetail with technologies like PCIe Gen 4. And with that being said, that's the technology that we're starting to look towards to really be able to efficiently drive 200 gigabits, as well as the CPU technology behind it, because you need a CPU technology as well as a PCIe bus that can really utilize the 200 gigabit interconnect. With that being said, we will look to dovetail at that point in time. As you look to other potential benefits of the 200 gigabit implementation comes into the switching time frame, and we will be bringing out 200 gigabit based switching in a time frame where we feel that it's completely stable and that our customers can utilize.
Well, great, Joe. Kind of a wrap-up question here. The top 500 is great and everything, but it leaves out a lot of the rest of the world. Does OmniPath have a role to play in like AI workloads and smaller type clusters out there in the enterprise?
Yeah, we see a lot of our customers today utilizing clusters and clusters based on OmniPath for doing AI, and in particular AI training. AI training does require a high-performance fabric like OmniPath, and so it is one of those technologies that's very communicative, has to be supported by a high-performance fabric to get excellent time to solution or time to train in this case. We have customers today like Texas Advanced Computing Center, Pittsburgh Supercomputing Center, TiTech, Tokyo Institute of Technology, utilizing OmniPath clusters to do AI and AI training. Good case in point was Pittsburgh Supercomputing Center worked with Carnegie Mellon, and Carnegie Mellon designed a AI implementation for doing poker. And earlier this year, they actually had a tournament where they took on 3 or 4 of the leading poker players in the world and had them compete against AI. And there was real money put up, which is interesting. And as it turns out, the Carnegie Mellon AI implementation, which was run on the Pittsburgh Supercomputing Center cluster, which is, again, based on OmniPath, actually beat those 4 poker experts. And so the interesting thing about that is with poker, you don't have complete information. You don't know what's in the player's hand. You don't know what cards are still in the deck. You don't know whether the person is bluffing or not. And in this case, AI was able to show its capability in actually beating those 4 poker experts. So it's a great example of it.
Yeah. Joe, I was reading about that case study, and it said that the AI was getting better as it went through the tournament, and of course, players show up with their skills, and they are who they are, right? They don't they're no better or worse at the end. So, pretty amazing case study there.
I was just going to say, the question is, did AI bluff or not?
Well, you would think it would have to be good, right? I mean,
yeah, you would think so. You would think so.
Yeah.
Well, Rich, I'd like to thank you very much for this opportunity.
Yeah, well, thanks for coming on, Joe. I hope we got a chance to set the record straight, and we look forward to seeing more from OmniPath and Intel in the future. And thanks for coming on the show today.
Thanks again, Rich, and happy holidays to you and all your listeners.
Okay. All right, folks. That's it for the Rich Report. Stay tuned for more news and information on high performance computing.